Welcome viewers. In this video we'll see the program to perform matrix multiplication using the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic matrix multiplication using the C programming language. So this matrix we need to use the two-dimensional array. We know that array is a collection of same type of data. There are two types available, single dimensional array and two dimensional array. Single dimensional array is a collection of data. Two dimensional array is the collection of data having two size available, row size and column size. That is nothing but a matrix. So we need to use the two dimensional array in order to store the matrix elements. Now we'll see what is the matrix multiplication. We'll see the dimension of the first matrix. So we need to decide some conditions are available. So based on the condition only we can perform the multiplication, matrix multiplication. So let us consider the dimension of the first matrix is m into n. That is number of row is m, number of column is n. Similarly, the dimension of the second matrix is p into q. Number of rows is p and number of column is q. Right. What is the condition for this? The m, this n. Number of column in the first matrix is equal to number of rows in the second matrix. Then only we can perform the matrix multiplication. That is, these row elements are multiplied with the column elements. Then all are added together. So that these two should be equal. So we'll see the example at the time you will able to understand clearly. So the column elements are multiplied with row elements. So these two elements should be equal. Right. Suppose n is equal to p. Both are equal means we can perform the matrix multiplication. In that case, the resultant matrix after multiplication, what is the dimension of the resultant matrix is nothing but m into q. A row in the first matrix, column in the second matrix. So we will get the resultant matrix is m into q, right? So m into n is the dimension of first matrix, p into q is the dimension of second matrix, n should be equal to p. Then only we can perform the matrix multiplication. After multiplication we got m into q as a resultant matrix. Right. Now we'll see the example. Let us consider 2 cross matrix and 3 cross 2 matrix. 2 cross 3 matrix. 2 row 3 columns. Second matrix 3 cross 2. 3 row 2 columns. Right. Let us consider this is the matrix A. This is matrix B. Having 2 row 3 columns 1 2 4 6 3 5. Matrix B 3 row 2 columns, right? 3 5 6 7 1 2. Now this condition is correct. This condition is satisfied. Number of column in the first matrix is 3. Number of row in the first matrix is 3. So that we can able to go for multiplication. That is, this 1 is multiplied with 3, 2 is multiplied with 6, 4 is multiplied with 1. Then it is added together. So these three elements should be equal to the number of row, number of columns should be equal to number of row. Then only we can perform the multiplication. That's why we are checking these three should be equal to 3. Number of column in the first matrix should be equal to number of row in the second matrix. Right. After multiplication, what is the resultant matrix? 2 cross 2. We will get the 2 cross 2 as the resultant matrix. Now we'll see the multiplication, right? How to do the multiplication, and we'll verify whether we got the same 2 cross 2 matrix we are able to get, right? We'll see all this. Now consider this A and B. How to multiply this? 1 is multiplied with 3. 1 into 3 plus 2 into 6 plus 4 into 1, right? These three column elements are multiplied with these three row elements and are added together, right? Suppose in matrix addition and subtraction is easy. 1 plus 3 only we are adding. But here we need to add, or we need to multiply these three column elements with three row elements and is added together. Right. The second, what we are doing, the same. This first row, this three column multiplied with the second column elements. 1 into 5, 2 into 7, 4 into 2. They are all added together. Right. Now consider the second, these three elements, 6, 3, 5. There 6 is multiplied with 3, 6 plus 6 into 3, 3 into 6, 5 into 1, all are added together. The same 635 multiplied with 572, 6 into 5, 3 into 7, 5 into 2. Now we need to add all these values, right? So 1 into 3 is 3, 2 into 6, 12, 4. This 5, 14, 8, 18, 18, 5, 30 is 21 and 10. These three are added. 3 plus 12 plus 4, 19. 5 plus 14 plus 8, 27. 18 plus 18 plus 5, 41. 30 plus 21 plus 10, 61. See this, now we got the 2 cross 2 matrix. The resultant matrix is 2 cross 2 matrix. See this 2 cross 2 matrix, we got the resultant matrix. Right? So the condition is satisfied. 2 cross 3, 3 cross 2, the 3 equal. So after multiplication we got 2 cross 2 matrix, right? Okay. So then how to frame the expression, equation? We need to frame one expression while doing the program, right? How to do that? C of ij, right? So the A is the first matrix, B is the second matrix, C is the resultant matrix, multiplication matrix. C of ij equal to C of ij. Why we are writing this? We need to add 3 elements. First 3 is added. First 1 and 3 is multiplied, then is added. 2 and 6 is multiplied, that is added with 3. 4 into 1 is multiplied, that is added with this 12. So 3 plus 12 plus 4. 3 times we need to multiply. These 3 results are added together. So C of ij equal to C of ij plus A of I into K. Normally I refers row size, J refers the column size. But here we need one more term. We need to multiply 3 times. So that one more variable is introduced, K. I into Ik into B of K into J. Here we refer the column, 3 column elements. Here we refer the 3 row elements, right? 1, 2, 3. These 3 column elements are multiplied with row elements. So that here we vary the column as K. Here we vary the row as K, right? So Ik into Kj. A of Ik into B of Kj, right? So the K refers column elements. This K refers first one means row elements. These column elements are multiplied with row element. This column element. This is first column element, second column element, third column element. That is multiplied with first row element, second row element, third row element. So that we are multiplying like this. So we can give the expression as C of ij equal to C of ij plus A of Ik into B of Kj, right? So this ij refers the for loop. We need to open 2-dimensional array. We need to open 2 for loop, outer loop and inner loop. Outer loop vary the row size, inner loop vary the column size. That we already know that. In that we are additionally introduce one more variable K, right? So here now we discuss the how to perform the matrix multiplication, what is the process and what is the condition for that. After condition, what is the resultant matrix or the dimension of the resultant matrix and what is the expression, right? So based on that we can go for the program. So we'll start the program. So the first matrix is M into N dimension. Second matrix dimension is P into Q. Resultant matrix is M into Q. The condition is N equal to P. This N equal to P, resultant matrix M into Q, right? Now we'll start the program. First include the header file, hash include stdio.h, standard input output header file is used for printf and scanf. Hash include conio.h, console input output header file used for getch and clear screen. Then void main, we start the main program. Open the brace. First step is we need to declare the variables. What are the variables needed? The A, first matrix, this is a 2-dimensional array. B, second matrix. C, third matrix. We declare with 3-dimensional, 2-dimensional arrays are declared. 10 into 10. Row size is 10, column size is 10. This is the maximum size. We can use within 10. We are normally in this program we are going to use 2 cross 3 matrix and 3 cross 2 matrix. But this is a maximum size. Otherwise we can declare A of 2, 3, B of 3, 2 also. Exactly also we can declare. But if you declare 10, 10, we can use any dimension according to our requirement we can use. So this is a maximum size. 10 into 10, 100 locations will be allocated. In that we can use the our required, that is our choice, right? So the maximum dimension is declared. This M and N is the dimension of first matrix. PQ dimension of second matrix. In order to open the for loop, we have I, J, K. One more term is available. K is also available. Right. Now we declare the first matrix, second matrix, third matrix, dimension of first matrix, dimension of second matrix, and variable required for loop. Then we can clear the screen in order to clear the previous content. Now we'll get the size of the first matrix and second matrix from the user. Printf, enter the number of rows and columns of first matrix. So the user will enter the two values. That is used by scanf %d %d. This refers the integer type. And M and N. Address of M and address of N located in the address, right? So the user what enter two variables stored in M into N, that is row size and column size of the first matrix. Then printf enter the number of rows and columns of second matrix. We ask the user to enter the size of second matrix. So user will enter two data, scanf %d and P and Q. First data stored in P, second data stored in Q. The row of second matrix, column of second matrix, right? Now we got this value. Now we'll scan the data. Now we'll get the elements of the first matrix, right? Printf, enter the elements of first matrix for I equal to 0, I less than M, I plus plus. We already discussed that. We are going to use 2 cross 3 matrix. 2 row is 2, column is 3, right? Then and inside this will vary the row, this will vary the column, right? So inside we have one more loop, vary the column, scanf and A of ij, right? First the element what entered, first elements are stored in A. How it will vary? First I equal to 0, I value is 0, right? Then it will go to the condition is correct, it will go to the inner loop. J also 0, this condition is correct, so it will scan the first data stored in 0 0, A of 0 0. First element is stored in A of 0 0. Then J plus plus, J become 1, I is remain 0 only. So the second element stored in 0 1. Then again incremented 2, I is 0. Third element stored in 0 2, right? So while incrementing to 3, it is the condition is false. J less than or equal to 3, not less than or equal. Should be less than or equal mean 2. So this condition is invalid, right? So it will go, this inner loop is terminated and it will go to the outer loop. Now J become 1. Again I will vary from 0, 1, 2 like that. So the remaining variable stored in 1 0, 1 1, 1 2. Then again it will go to the outer loop 2 0. Then the 2 I will be varied to 2, 2 0, 2 1, 2 2. So the correspondingly the elements are stored in the variable, right? So here only 2 rows are available. This is not invalid. This will be invalid. Okay. Only these 3 elements and these 3 elements. 6 elements are available. When Ji equal to 2, the condition is invalid. It will be terminated. Right. So it will be executed 2 times. Right. 0 0 0 1 0 2 1 0 1 1 1 2. If I become 2, the condition is invalid. Right. Now we'll go to the second matrix. Second matrix is the 3 cross 2 matrix. 3 row and 2 column. So we are using PQ, right? This will be 3, this will be 2. So the inner loop will executed 2 times, outer loop executed 3 times, right? 0 0 0 1. Then it will go to 1 0 1 1. Then 2 0 2 1. Like that it will executed, right? I J. First 0 0 0 1. 2 means terminated. Then 1 0 1 1. Then 2 0 2 1, right? So we are having this 3 row and 2 columns, so that corresponding values are stored in B of ij. Now we got the array elements from the user for first matrix as well as second matrix. Now we'll go to the multiplication process. So before going to multiplication, we need to check the condition. If n equal to p, this is the equal operation, equal to operator, whether it will check both are equal. One equal mean assignment operator, p will be stored in n. Double equal mean it will check both are equal, right? So if it is equal only, we can proceed for matrix multiplication, right? So before getting the first and second matrix also, we can check this value. After we can check this condition after getting row size and column size of first and second matrix before getting the elements also. But here we got the elements now. Thereafter we are checking. Before getting the elements also we can check. So here the loop is open for I equal to 0, I less than m, I plus plus. J equal to 0, j less than q, j plus plus. Right. We already discussed that this m cross n is the first matrix, p cross q is the second matrix. These two should be equal. This is the resultant matrix, right? So the resultant matrix is m into q. So we are using m, we are using q. Then only we get the resultant matrix. Here what we are using, 2 cross 3, 3 cross 2. This condition is true. The output, the resultant will be 2 cross 2. So we are using 2 cross 2, right? The row size of the first matrix, column size of the second matrix we are using. Then only we will get 2 cross 2 matrix, right? So this is the resultant matrix. Resultant matrix dimension is m into q, that is 2 into q that we are using. Right? We are declare C of ij equal to 0 because we are going to add C of ij cumulatively. In order to get, we need to add 3 variables, right? First column, second column, 3 elements are available. 3 times we need to multiply and add so that it is 0. For k equal to 0, k less than. What is the variable here need? Here 3 is needed, either n or p, because 3 times we are going to do the process. Right? Multiplication is done 3 times, 3 variables are added together. How many times we need to multiply? Based on this value, either n or p. Right? The column size of the first matrix, row size of the second matrix, that will decide. 3 means here 3 elements available, here also 3 elements available. We need to perform 3 times. So here we are using n, right? The k is used as n, I is the m, this j is q, k may be either n or p, so that we are perform 3 times. So it is very clear, right? The first matrix while read we use m into n. While reading second matrix, we use p into q. While doing the matrix multiplication as well as display, we need to use m into q. This is the resultant matrix. The inside process multiplication and cumulative addition, we can use n or p, right? It is very clearly given. So C of ij equal to C of ij plus A of ik into B of kj. So that automatically the column element, this is row into column element, this is row element. This column element of the first matrix multiplied with row element of the second matrix. Cumulatively it will multiply, then is added together. Initially 0, so 1 by 1 it will add. But in our example we have 3 times we need to do the multiplication. 1 by 1 it will multiply and store in the C, corresponding C, right? First element is C of 0, 0, that is 0, 0. Then it will multiply. Then it will go to 0, 1, 0, 2. Like that it will vary. So after this completing this loop, the elements are multiplied. Now we can store, we can display the resultant matrix. The resultant matrix what is applied, we need to display. Right. Print of the resultant matrix is /n means after printing this line, it will go to the next line. For I equal to 0, I less than m, I plus plus. For j equal to 0, j less than q, j plus plus. So resultant matrix also we are using m into q, right? Print of /t. This /t what will happen between the element, it will provide the tapping. After print the first element, some space will be provided, C of ij. So this inner loop will print the entire first row. After printing first row, this loop is terminated, it will go here /n. After printing first row, it will go to the next line. So that we'll get the in a matrix format, right? So the first row printed by using the inner loop with the tapping. So the tapping available between the elements. After that, before going to outer loop, we go /n. So it will go to the next line. Then only it will print the second row. like that we'll get in a matrix format. So we close the process. Else, suppose the condition is not correct, the given condition is not correct, we need to print the matrix multiplication is not possible, right? We can print that. Before in this program we got the matrix element, after that we are checking. Before getting the matrix element also we can check, so that we can reduce the process. So get ch and close the program. Get ch mean it will wait for getting the character, until that we can see the output of the program. Then close the brace. Now we'll see the output. There are two cases of output available. One is matrix multiplication possible, another one not possible. We'll see both the output. So the first output is the possible, matrix multiplication possible. Enter the number of row and column of first matrix. 2 into 3. What we discussed in the example, the same size, 2 into 3. Enter the number of rows and columns of second matrix, 3 into 2. These two are equal, so we'll get the 2 cross 2 matrix as a resultant. Enter the elements of first matrix, 1, 2, 4, 6, 3, 5. Enter the elements of second matrix, 3, 5, 6, 7, 1, 2. What we discussed in the example, same elements. So the resultant matrix is 19, 27, 41, 61. But it will display not like that. 19, 27, 41, 61. Because we use the tapping here. And also /n here. So that it will go to the next line. Right? It will not print like this. It will print like this in a matrix format. Right? First element tapping second element. Thereafter go to the next line. First element tapping next element. So it will print in a matrix format. Right. The one more possibility is the condition is not correct. Right. Enter the number of rows and columns of first matrix. It's not second matrix. The first matrix is 3 cross 3. Enter the number of columns of second matrix, 2 cross 2. The condition is not satisfied. These 3 should be equal to 3. Right. Here not satisfied. Right. 3 cross 3, 2 cross 2. So these two elements are not equal. These two elements should be equal. Then only you can multiply. So we display matrix multiplication is not possible. Right. The condition is not satisfied, so that we cannot perform the matrix multiplication. Right. So in this program we discuss how to do the matrix multiplication, what is the condition, what is the resultant matrix, what is the process to do the matrix multiplication, and we discuss the program, how to write the coding. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.